Hi friends, so we are there in the fifth lecture of prognostics and health management, a systems approach. We have been talking about two major approaches for prognostics and health management. One is a data-driven approach, which has become quite popular, especially for bearings, lithium-ion batteries, and many rolling components of the system. So that means it is equally being applied to mechanical as well as electrical and electronic systems. The other approach is we call physics of failure, or maybe I would call, if it is applied to the mechanical engineering, it is mechanics of failure. We'll call this approach. But today our subject is electronics, PHM for electronics. So we'll call physics of failure approach for PHM of electronics. You will see the different model, different method. In fact, quite often this approach, that is physics of failure approach, is also referred to as science-based approach. Why science-based approach? Because we start from material-based properties, their degradation, what are the phenomena or mechanisms that are going on or developing at the level of grain boundaries, and even further to micro level, and that is causing the components failure. Now we know that components don't fail in isolation. Either there should be some cause or some mechanism for it to fail, or environmental condition or operational condition for it to fail, or simply the component has aged and now its resilience for the application has been reduced. So let us see what is physics of failure approach and its applicability to PHM, especially for electronic components. Let us see, in physics of failure approach, we call life cycle aspects. What do we mean by life cycle aspects? Any component, before it comes into the application domain, it has got certain stages, and those stages are, first it is conceptualized, then it was a model that was created on the drawing board, and then a concept sort of thing was floated. Okay, what are all the requirements, and then manufacturing processes, tolerances, quality, all those issues, and then it enters into manufacturing. And in manufacturing, you can see the tolerance, machine tolerance, and all those aspects, they come into the picture. And finally, again, the component goes through the quality control aspects, and then it is launched. If everything performance is good, like testing is successful, then it is launched in the public domain. So that means it is in the use domain. Okay, and once it completes its life cycle, and maintenance is part of that life cycle. Operation and maintenance is part of that. So that means how well then when we talk about the operation, there are environmental loads and there are operational loads. We'll talk about them in this thing detail, and then finally we come to the next topic, that is failure mode mechanism and effect analysis. There is a FMEA family procedures. To begin with, it was failure mode and effect analysis, then failure mode mechanism and effect analysis, then it was failure mode mechanism and criticality analysis, and then later on it is quite popular even in diagnostics also. So failure mode, effect and diagnostic analysis. So there are many various manifestation of this FMEA approach, which was initially designed as a brainstorming tabulated approach. Now it is being applied in many fields. But when we talk about the mechanisms and all, it is basically we are trying to address why the component has failed. So that means we are going into the root causes of the component, and we are incorporating the lesson learned into the design so that it should not, to the extent possible, fail in the use cycle. Okay, and then we have temperature is a stress, humidity is a stress, which fails, or if they are not maintained, we will have electronic component failure. But then there is one more special mechanism that is called fatigue failure. And mostly when we talk about the electronic component which are operating in ground benign condition, it is the thermal fatigue that we talk about. And then of course at the end of the day we do virtual qualification. So now with this physics of failure approach and its availability and the facility that it offers, before the component is fabricated, all the modes can be studied a priori, and those lessons learned, that means a good part of you can say feedback learning, it starts during conceptual phase when the drawings are ready, and that is incorporated. So the work or the performance of the component can be expected to be better in the field. And then we talk about what is the specific PoF model that offers for PHM. So this is one. Fourth and fifth topic, they are directly talking about applicability of PoF or for PHM. And the last is canary and prognostics. Canary is a special and interesting component of PoF approach. In fact, there is quite a bit of PoF models that are used in canaries also when we talk about prognostics and health management. The canary word has been, has come from a bird which is strategically located in, which was like, olden days, it was located in the mines to detect a priori about the release of the gases or hazardous gases, I would say, so that workers can be informed and precautionary arrangements can be made. So let us talk about the first introduction, that is week 5, first lecture, introduction. So here we will be talking about the physics of failure approach and its background and all. So it's like this, that physics of failure approach was primarily designed for reliability, because that was a time the first lesson was learned that we have component, but when we go to the field or especially wartime ecosystem, then the component fail miserably. So this lesson was learned, and in around 50 after the First World War, it was decided some method should be developed to reduce the failure rate of component into the. So initially the handbook like procedure was evolved out, and that handbook will tell us what will be your failure rate if the condition is like this, loading is like this, and then there are learning factors and so many factors. So MIL 217 was the, I think we can arguably was the first MIL handbook that was available in open domain, and that was used. But then there the limitation was that we are getting the failure rate of the component, and of course we are trying to build a system model or card level model on that. But then what kind of common effects or common cause failure, or what are the human induced errors, that like all those details which were at the root of it, it was really difficult. So this approach also evolved, that we'll be discussing in the other slide. So later on it came as a reliability based approach. So reliability approach means failure and it's a mission time, or demand and its mission time. So that's how the scenario, and this was a parallel development even for electronics also, because electronics also used for process system, that is for continuous operation of the safety critical system, as well as for safety system. Safety system means when the demand is generated, the safety system has to be activated, and electronics was at the core of it. So and then slowly, because probabilistic notion also has some limitation in the sense that it tells the instant of the failure. It tells the probability of the failure. But what about the instant? And maintenance management is all about when a component is going to fail. Okay. So then physics of failure approach, which provides the estimate of life cycle consumption, and then it talks about the remaining useful life also, and then other prognostics approaches. So now PHM is considered to be advanced approach, still remaining with the elite labs and industries which are using it, but still it has not entered the common domain, and that potential has to be explored. And then of course we will be talking about failure handbooks. I have discussed about it. And then why physics of failure approach? Physics of failure approach is, even if it has got certain limitation now, probably being a science-based approach, it can be a very promising approach in the future, especially for the prognostics and health management. So, what are the life cycle aspects of electronics? So, electronic systems are basically, one good thing is they are essentially passive in nature. Why we are saying in one word, if I have to explain, active and passive? Active means there is no relative motion between the part, which is typical with electronic mechanical components. Okay, so that is an advantage, because passive components are supposed to be more reliable compared to the active component. And this particular philosophy has now driven even the systems where active components are used. Now there are system design using the thermal hydraulic features or any other electrical feature, electronic feature, to have, to the extent possible, the passive systems, and physics of failure and reliability. Though its a root is there somewhere in the reliability, but now it has got a very strong connotation as part of data-driven approach, where PoF, fusion of physics of failure and the data-driven approach, they are having a promise of predicting the instant of failure with a minimal level of uncertainty. Okay, and if that has to happen, especially for PoF, what is required is virtual qualification, because in the real-time qualification or hardware qualification procedures that are can call physical qualification, they consume a lot of time, resources, and you cannot do number of iteration simulation because the lot of costs are involved. It's not that cost is prohibitive, but then finally a system has to be built so that it serves its intended purpose. So virtual qualification is a very important tool. Only condition with virtual qualification is whatever our models and methods and environment that form part of the life cycle use of the component, that should be reflected, and the model should be correct to the extent possible, in the sense of epistemic and aleatory uncertainty. Because aleatory uncertainty is random thing. It will remain part of a system, but at least epistemic uncertainty associated with the failure of the component, and of course the objective is the component should not fail. So from this platform, I would say that the biggest promise of PHM, whether it is physics of failure approach or data-driven approach, is to eliminate the failure or to reduce the consequences of failure. Failure is coming, you know that remaining useful life has been approaching, and then we can take management action depending on, and that management action is very important. Most of the literature, they talk about prognostics, but there are very few are known that talk about seriously how management action, because management actions are associated with the domain or a plant. So that is why, but then there should be models and methods to have then intelligent, because PHM is all has become possible. It is because of intelligent AI ML algorithm. We will see in the coming lecture, and that's why it has got become so popular. Now, when we develop anything, there should be standards available. And I don't know whether in this week I'll cover, but definitely there is a prognostics and health management standard that is available, and it is from the NASA, I guess, or the Society for PHM. So that standard, and that means there are some the criteria that have to be met, and that's why we say that yes, it is ready for entering into the market, or it is ready to go out of the labs and see the thing. Like even if we talk about the PHM, we have condition based maintenance mostly for electrical or mechanical components. So when we have come to condition based maintenance, there is a additional work required, and there is nothing than a statistical model and statistical model and intelligent model that have made it possible. Now, PoF based PHM will be discussing. This is the subject of our this week. And final remark, I'll leave it for the end when we complete all the 5 lectures in this module or in this week. So, this I have given that World War, electronics reliability, handbook approach, MIL 217 in my previous slide. I have talked about it. A notable thing is the limitation of MIL approach. They were realized, and over a period of time we have evolved from MIL 217 to MIL 217F, and now it is a MIL 217 plus. That means it is an American military standard. Okay, so basically it was designed for military applications. But if you look at the models and methods and data that have been provided, probably it can be used in other industry also, taking care of domain specific characterization. So I call this approach as a handbook approach. And then still there are comments in open domain and all. So now there is a move as far as this reliability approaches are concerned to physics of failure modeling, which provides time to failure. Time to failure means, again, it is a one of the many manifestations of RUL, remaining useful life. Okay. And here in PHM we achieve this target when we put PoF as part of PHM, so we get remaining useful life. So in just short, how these things have evolved. Initially, when 50s or 60s the systems were built, or even before that, the quality specifications used to be one of the things that will tell us, okay, product has been designed as per the specification. That means it is complying the specification, and then it will go into the manufacturing stage. Okay, and in manufacturing stage also it will be seen that quality controls are the forming part of it and all. So that way, if you see, quality assurance program is there applicable all through the reliability program, whether it is a quality assurance program because in 60s it was only quality. Reliability, or 50s, reliability, the concept, it was not at all visibly available or in the literature. So we can say, but then the MIL handbook approaches and all and other data collection procedures, they made it possible to estimate failure rate. And MIL handbook 217 and all, they were capable of handling the failure rate of the component given the stress level, quality, the complexity of the component, and so many other factors specific to the component. But failure rates was not sufficient because we wanted to know what is the probability of the failure. Okay, and probability of failure, that means we can compare different component with different parallel systems, so that we can know which one is performing better. So probability of probabilistic notion of reliability, that tells us what is the reliability of the component, how you can be depending on from one component to other component if reliability levels are different. And now the science has approached, we are coming to the RUL, and RUL is being talked about. If we see the literature, many papers and publications, and there are developments that are going on in the field, but quality remains one of the aspects here. So here I would like to say one point: all across the human factor is involved here. Whether it is quality level, failure rate level, and probabilistic and RUL. So every stages should have a lens to see where human can, of course humans are doing great job and all that, there is no doubt about it, but it is a human error are possible however remote it is, and those kind of element should not affect any of this ladder that we have. So this is the background, and with this background we'll start with talking about mill handbook 217 and their applications. So as I mentioned, the mill handbook was actually developed for, because it is called military handbook 217. So for military, so application domain was military, but in those days very limited data sources that were available. So this was a very organized handbook, and for quite some time, and even now also people are using it. So it's an advanced version, MIL 217 plus whatever. Then Telcordia, it was or Belcor, this was applicable for telecommunication, because telecommunication uses some component which are not there in other domains. So this approach was developed, and again it was like a handbook approach only, and it became quite popular for in telecommunication domain. Now GJB Z211, it was basically a Chinese approach for reliability prediction. They call it the manual for electronics. So that means there were dedicated efforts from many corners to study electronics failure, because electronics are at the core of any system that I have talked about it. So that's why it was so Prism developed by reliability analysis USA, the US Air Force. So you can see it was mainly for you can see this were the for military grade, that is armed forces. This was for Air Force. Because in Air Force also mission reliability is very important, and all the things should be tailored from the mission critical point of view. And the latest one is FIDES. FIDES is basically a European approach. France is leading it, and then it's a multi-domain methodology. In fact, these were the approaches, what we saw were the domain specific. For the first time, we have this, it has become domain specific even in print also. So that means many industries like have been accommodated their application part of it, like aeronautics, space, navy, automotive, railway, industry, production and distribution of electricity, telecommunication, even information technology, which is a relatively new field compared to all this, and home automation system, electrical appliances. So that means FIDES is a development, but still the if I would say that FIDES has still remained limited to the specific domains and specific areas. So it is not as popular as our MIL 217 foundation that we have. Okay, so but the reason is it is one of the latest approach, and it will take time to reach all the corners, because it has got a very generic nature in the sense that it can be applied to any domain. So its potential is very high. Then MIL 217 plus among the US military 217, 217, this was the thing, and finally we have in late 90s this 217 plus came, because there were so many limitations with 217, the initial handbook. All those things they were overcome, but still people have the urge of going to the PoF approach, because one, we are doing everything based on our requirements, and then my science is so advanced that even domain specific labs like accelerated testing, then microstructural analysis, I can do for my component. So that means physics of failure approach, it provides that open offer to anyone to get enriched and develop their own model and methods for their applications. My last comment is, even though the above proposals are referred as handbook approach, there are software environment that are available wherein this approach have been embedded, and our job is simply use that software, use the indicators or selections, applicable for our domain like temperature, humidity, or type of use or complexity level and all, and you can within short time you can for component wise we can find out the failure rate or reliability. The traditional handbook approaches are mostly based on assumption of constant failure rate. So this was one of the limitation, but the new approaches are providing like viable approach has become very popular for time to failure data. So why viable approach has become popular? Because it can viable distribution alone can offer the three models, that is for constant failure rate, for log or log normal or normal distribution, and other distribution also can be seen because there is something called beta factor, which is called slope factor or shape factor, that will tell us how far we are from a particular distribution. So accordingly we can choose. Later on we can have, as I presented in my earlier slides, we can zero on to the applicable distribution based on the regression and other methodology that are available. Okay. Now significance of PoF is what? It is something, it is giving you type of failure. Here it actually targets instant of failure. So that is one of the biggest point, because then I can use this thing very effectively in my maintenance planning and management system. It's not that probability is not useful. Probability is useful for designing the maintenance program, because we will know from there which component is more important, most important, less important and all that. And that's why probability and instant of failure, these two together form at they are at the core of systems approach. So systems approach in electronics, in fact system you can call even a card can become a system, because it is a amalgamation of many electronic components on one board. Okay, and then we can have something even a complex engineering system like a fertilizer plant, or you can say oil industry, they are also, but the complex systems have a definition. Electronics of course is a part of that one and play a critical role, but there the objective is that safety is an overriding factor, So and then there are new mechanisms they come in there actually, like common cause failure, human factor. Yeah, we all know that in the history of the accident has to be seen, the human factor has been considered to be one of the major contributor to the accident. This is I am talking about print. One comment can be given here is the human factor is there right from conceptual to refurbishment or to system going to the shutdown state. So human has to be there, but then why we are considering, because in when we have emergency condition, human performance is very critical to this, and probably humans have done wonderful things, but there are something, and now there are like in human factor development also many advancement has come, like simulator things, and there are many gadgets that have come 360-degree view and all that. So we expect that they will come down, and of course in critical industries the training mode itself is very elaborate, and it goes on from couple of years. That means after graduation a person does the training, and then only he is found after was walk downs and all, then he is authorized for a particular job where he tend to take a decision. Advances in electronics, yes. Earlier electronics were started from wall based to relay based to solid state logic, and now it is a transistor, that is microprocessor, controller and all. So there is a huge load on electronics industry to reduce the size and to expand their application. So we will see that complexity, and from that point of view electronics industry and the physics of failure approach, because they can go up to nano level and micro level also. Science of advanced prediction, yes, that is evolving and there is a need, and so that failure should not occur. And then role of BHM, so in PoF either it can be independently used as a PHM approach, or it can be used with a data driven approach. It is called normally integrated or fusion approach. Okay, and then there something like electronics, there are canaries, PoF, like there are canaries. So canaries also basically they require at the end of the PoF can be vital for common cause failure. Why? Because Common cause failures are there when redundancy is knocked off, and that is knocked off because of some mechanism. It could be humidity, it could be high temperature, it could be flooding, or it could be fire. So common cause failure is sitting there, and PoF is the right approach to take care of environmental as well as the component specific models. Okay. So, okay, life cycle aspects and all that. Probably earlier there was something called bathtub curve. We'll take those period, and I mentioned about viable distribution. So now you have your own data. Try to assess the model, and then you can see initially this one shows the beta is equal to less than 1, hyper exponential model, then exponential model when beta is equal to 1. So that means now we can characterize the data, our own data. Here y axis it is a PDF probability density function, it is time here, and beta is equal to more than 1. You can see here it is approaching the log normal or normal distribution. So log number we can see here. If you have more data and all that, because independency of the data has to be handled, and that's how we can have these methods. So and then here we are saying why it is more applicable, or you life cycle aspects of POS. The first part is data collection. We'll talk about it. It is not the component specific data, it is the environmental data. It's a data which it will be facing during the its application, that means in market or in the industries. So that also has to be worked out, and then based on that a model has to be created. So PoF essentially means developing a time to failure model for a component, and we'll see in the next slide. Okay, and now since the technology has evolved, that on Weibull itself there are technologies have been developed around Weibull, and it has become a subject in itself. So that means that much deeper dives are there to come to the accuracy of data that we use for any application. Now PoF perspective. Again the same thing, I am talking about this distribution and all. Now let us focus about the failure mechanism, because failure mechanisms are critical. Failure mode, okay, one thing. Failure mechanism is critical because it requires a science-based approach, and it forms almost like if I virtual qualification and all, if I do modeling itself, it takes almost like 50% of the effort for in PoF, and you can see that how beta value and all they can help us designing the test or simulations or model validation for a particular value of beta, because it is the rate of failure or probability density function of failure that determines what we should do. Okay, and then in stages we can study the failure mechanisms and its applicability, and that's how we have a PoF perspective. Now if in a crisp way you would like to understand, because we had two methods, statistical reliability and PoF based reliability. We are referring here reliability only, but now we have come to the time to failure and all. So we can say product is reliable, that much we can say, and how where it ranks, specific acceptable level, it is acceptable or not, and so given the mission, because reliability operates in two domains. One is time domain, other one is load, stress and strength domain. So we are talking about these two. So reliability can be given, but here product is reliable if we are confident that it will not need maintenance for a specific period of time. It's a wonderful factor that we have, because we are able to come to this aspect because we are given time to failure, and time to failure also with uncertainty associated. If uncertainty associated with the estimation is more than the acceptable uncertainty level, then that estimate doesn't mean anything to us. I mean, it asks for go and further fine tune so that the uncertainty curve or it becomes really very small, that is 5% to 95% band, they should come very close around the mean. So that's where the condition is. Matrix is failure rate and mean time between failure for statistical reliability. But here we are giving in the language of maintenance. The maintenance is matrix MFOP and FFOP is given a confidence. Maintenance free and failure free operating periods. Failure free, maintenance free operating period. Virtually I am telling my component will not fail. we are tending towards a situation where my component will not fail. And maintenance, yes, because degradation is there, so I will do maintenance, but I will be using the full useful life of the component. That is a promise which comes here. Categorize useful period failure as a random failure. Basically, this whole game is around random failures, because epistemic uncertainty we can manage, but random failures, they still remain as part of the aleatory uncertainty. Failures are assigned to specific clauses, useful for estimating overall reliability of product system. And here failures are assigned to specific causes. Okay, failure causes and mechanisms, useful for focusing on each and every product unit. So it is much more comprehensive and detailed and resource consuming. Probably that is one of the reason it is taking time, because we need advanced labs for this kind of thing. So this week we saw background of reliability and the in fact, we say that PHM, this is a relatively new word, but if you see the older system also, which are built into 60s and all that, in one of the lectures I have addressed this. Even there, some coupons like things were used to be put, and those coupons will give us an idea what is the level of degradation, like a pipeline, underground pipeline. If I put a coupon or a coupon in number of coupons for like say a lifetime of 30-40 years, those coupons will provide me information what kind of corrosion level has happened and what kind of reduction in thickness of the pipeline has happened, because underground pipelines, especially which is embedded into the earth or the soil, it cannot be evaluated. So the coupons you have to pull out from the location. Strategically coupons were put. Even for pump also, there were pumps from some company which provided 1 meter like thing, where the white, green, indigo, no, not indigo, orange and red. These colors were shown. As long as it is in the green zone, nothing to worry. When it goes to the next zone or the red zone, then that means failure is approaching. Failure has not happened, it is approaching. And they were simple devices. It is used to sense vibration or temperature, one of the parameter, and it will tell you that now device has to go under maintenance. PoF, a science-based framework, that is a more promising than this, because it starts from the root cause. There is something called root cause of failure. So it starts from there. So there is a good promise in root cause analysis. The promise is that failure will not occur again. If that failure has occurred, that means root cause analysis was not done to the kind of detail, has not been done, and again it has to be repeated. So role of PoF based approach for PHM, it appears very promising, and we will be discussing only PoF based approach for PHM in especially last two lectures. Power and limitation of PoF, yes, we have discussed about it. Role of PoF in integrated framework to complement and supplement data-driven approach. Yes, it is very promising, because directly it is reducing it tends to reduce the uncertainty, and it should not induce new problem. So if there is any conflict of output from PoF and data-driven, that need to be resolved, and I think now AIs are competent enough to take care of this kind of approaches.